And in 6.5, we're still going to look at rational functions. And when you see the word rational, you think, really? We just talked about this. Fraction, thank you. Okay. So we saw what a rational function looks like when there was a number up top and x on the bottom. You don't have to do this, but it looks something like this. There were two portions to the graph, okay? And then we had a horizontal line that our graph will never touch called a, what's that word? Asymptote. And then there was a vertical line that our curve didn't touch. That's the vertical asymptote. And then we did a couple ones where the vertical one moved a little bit. The horizontal one didn't move, but the shape was always the same. Okay? That's generally what happens when you've got a number up top and an x on the bottom, or an x, say, with x plus 4 or x minus 3 or 2x minus 1. Right? That's what the graph's going to look like. But what happens if it's an x squared? Well, if you think about it, okay, remember when we graphed the previous ones, we did the horizontal asymptote, we did the vertical. And I told you that all the graphs that we're going to look at, the horizontal asymptote is the x-axis, or y equals 0. Okay? We know that's going to be, we know our graph is not going to touch. It's going to get close to the x-axis, y equals 0, but it's not going to touch. Remember how we found the vertical asymptote? The vertical is the same as the non-permissible value. What value of x would make this function undefined? 0. So that means x cannot be 0, which means the vertical asymptote is x equals 0. So it's going to be the same. Now, to see what it looks like, I gave you a whole bunch of different values of x to plug in. But let's, you know what? I don't think we have to worry about so many of them. Let's take these ones out. Let's take the 3s and 1/3 out. We can save ourselves a little bit of time. So what is 1 over -2 squared? Sorry? What is 1 over -2 all squared? 1 over 4. Not -4, because the -2 is in parentheses. So 1 over 4. So -2, 1 over 4. What about when x is 1, -1, pardon me? 1 over 1, which is 1. And if x is -1/2, well, we might have to do a little bit of work here. So it's 1 over -1/2 squared. Well, -1/2 squared is 1/4. And what's 1 divide 1/4? Same as 1 times 4 over 1, which is 4. So we can see that we've got a curve going on, and that we know we can't touch this vertical asymptote, we can't touch this horizontal asymptote. So we've got a curve that looks like that. Remember, 1 divides 0 squared, that's undefined, which means we skip over the graph there, because there's no point on the graph there. Well, 1 over a half squared will be the same as this, because a half squared is a quarter. 1 divided a quarter is 4. So 1/2 is going to be 4. You could probably even guess what the next 2 points are going to be without calculating them. It's going to be 1 and 1/4. So 1, 1, 2, 1/4, and we get a mirror curve like so. So remember when we did 1 over x, we had a curve here and a curve opposite corner, opposite quadrant, or kitty corner. Okay? Here, when it's x squared, okay, you're going to get what I call a volcano-like shape. Yes. What's that? I mean, it will be, but that's beyond what we're studying. Yes. Yeah. What do you mean, how would that work? If you did this, if you did a negative in front, right, then it would put everything down. So it's possible that it could go. Okay, what's the x-intercept? Really? No. None. What's the y-intercept? None. What's the domain? X can be everything except it can't be 0. And same with y, or no? You sure about that? It's not the same graph as the ones we did in the previous lesson. What's the lowest y value? But we don't include it. Like it goes to 0, but it doesn't include, right? Isn't that the lowest? Yeah, it doesn't go below. Well, hang on. It can be from 0, but not including, all the way up to infinity.
You don't include the 0, you do a little
My point is that we're not using the not equal thing.
As I said, if you don't finish.
You can write it using interval notation. So how would you write everything from 0, not including, to infinity?
Negative b, not included 0, infinity.
Don't give me the not in. Okay. Bracket or parenthesis, because we don't include 0. And we always put a parenthesis around that. Now, I suppose if you did do if you tried a not equal thing, the only thing that you could do is you could say y is not negative. So how would you say that? You could say y is not less than 0. I mean, I would accept this. That means y can't be negative. Okay? But I would probably go to interval notation with this one. Okay, so that's what it looks like when we've got an x squared on the bottom. What happens, and there's two different types of examples. What happens when we have a number down there with the x squared and we're subtracting or we're adding? Okay, we're going to look at one of each. So let's do the same method that we did when we started working on other ones with if there was just an x in the bottom. We checked the horizontal asymptote, we checked the vertical, okay? Then we did like a little mini table of values, right? Around the vertical asymptote, okay? Well, the horizontal asymptote is always going to be this. This will not change for you guys. The vertical asymptote is the same as the non-permissible values. So what values of x would make x squared minus 4 equals 0? Positive and negative, which is? Right. Remember, this is one of, now you could factor this one, but this is one of those quadratic equations where there's no x term. So all we have to do is move the negative 4 over to the other side and then take the positive and negative square root to get our answers. So that means x can be plus 2 or x can be minus 2. That means there's two vertical asymptotes. X equals 2, x equals negative 2. So this is a little different than what you guys have seen. Because now there's three sections of the graph, isn't there? There's this outside one, there's this one inside, and there's this one here. Well, it is, don't sketch this yet, but it is going to look like this on the outside. It will look like that. Don't sketch those yet because we got to be a little bit more precise. The question is, what's the shape in between? Okay. So to find that out, we need to do a little table of values. And remember what I said, how to do the table of values? Pick one to the left of the asymptote and one to the right. So if it's negative 2, we're going to pick negative 3 and negative 1. And if it's positive 2, we're going to pick 1 and 3. And we got to calculate these. So what is 1 over negative 3 squared minus 4? Well, that's 1 over 9 minus 4, which is 1/5. So negative 3, 1/5, it's pretty low. Wouldn't it make sense that this would be the same answer? Because it'd be 1 over 3 squared minus 4, which is 1 over 9 minus 4, which is also 1/5. And remember, we know the shape that it's going to take, don't we, in these two sections. It's going to go like this, And it's going to go like this, and it's going to go like this, and it's going to go like this. The question is, what's happening in this section between the two asymptotes? Well, let's see. -1, 1/3, which means +1 would also be 1/3. So we're going to have this and this. A little lower. Should be a little lower. What? -3. Yes, -1/3. Should be down here. Come on. Okay, well, that doesn't help me very much. That. Okay. There is another point that we could find. How about the y-intercept? What would the y-intercept be? So we make x = 0. So that means we get y is equal to 1/0² minus 4, right? Which is 1/-4 or -1/4. Let's plot that up here. So these are 1/3, so this will be, it'll be close to the origin, but not quite. So we can see actually what shape it will take is an upside down parabola. It will go like this, and remember, we can't touch. We've already established. And it will go like this. You can't touch. That what? And the one I like to call this is an erupting volcano, which means lava's coming up. Just try to visualize. Okay, and if you can't, let it go. Pardon me? Kind of looks like a bug. Like it's an upside down bug. It's an upside down volcano. How could you have an upside down volcano? Yeah, but this stuff is kind of like coming up. God, just, you know what? Call it whatever. Whatever you want. Call it whatever you want. Call it like double curve upside down parabola. I've been calling it this for like 30 years. I don't care. Because
why? What she said.
Anyway. All right. So, vertical asymptote. Horizontal asymptote. Y = 0. Always. Vertical asymptote, we determined there were 2 of them. One at -2, one at +2. The x-intercept, because there's a horizontal asymptote, will always, no, none. There is none. There is none.
I know I thought it.
There's none. Just to be sure, there's none. In case you have, really? Well, really? Well, like, what do you think? I'm gonna like run out of here crying? They said I was like,
No one wants.
okay.
You need to have.
Anyway, what's the domain? X can't be 0. How about the range?
That negative, one.
No, because part of the graph is below.
Y cannot be negative 1/4. Y can't be closer to that. Oh, there it is. I don't know. Can you come in?
Okay, we're all good. We're all good here. We're all good here. We know that it's not, we know the range, we know it's not going to be 0. Okay? But could it not be others too? Well, like, okay, we agree that it goes down to negative infinity, right? We agree that it goes up to positive infinity, but we've got a section in here. Can't be 0? It goes all the way up to here, right?
Yeah. Okay. So it ends the negative. Isn't that positive third? I don't know. You tell me now. I'm stressed. It's stressing me out.
Okay, think of the portions. So the upside down parabola goes all the way down to negative infinity, comes up to negative 1/4, but doesn't, I'm sorry, but does include it.
Included?
Yes, because that's the y-intercept, isn't it? And then the upper portion of the graph, doesn't it go from 0, not including, all the way up to infinity?
Why can't you just go 1/3 included up here?
1/3?
That's where we started.
No, you're confusing that. But it can go lower than that.
Oh, it can.
Yes. Okay, it can go like 1/9, one.
But this can't go lower than 1/4.
It can't go higher.
Yeah.
Right.
Why is that? Be serious. I don't know.
No, I know, but there's a gap there, isn't there?
Yes.
So there's a gap between, because it goes from negative infinity, goes all the way up to negative 1/4. And then there's a gap. And then it's the vertical or the horizontal asymptote at x equals 0, at y equals 0. And then it goes up forever. So it's like there's a gap between here and here. That would be a difficult one.
I just don't get why the other one, 0 is not included. But they both start at a place.
Like this one goes negative infinity all the way up to, but not including negative 4. And then you've got to think there's like a gap here.
Yeah, I just.
Okay. I know it's a little hard to wrap your head around. Okay. But you can see, like, the point I'm trying to make is rational functions. There's so many different types of graphs for rational functions. It all depends what's in the numerator and denominator. I'm just trying to show you a couple, what they look like. Okay. Okay. Let's move on and look at this one. Okay. I'm going to pull this out to make sure I'm doing okay. Oh my God, I graphed that wrong in my notes. Okay. Horizontal asymptote. Y equals 0. Automatic. Vertical asymptote or the asymptotes. It's whatever values of x will make the denominator equal to 0. So I have to figure out what this is. X squared plus x minus 6 equals 0. Okay. How do I solve that? You got to factor in. When there's an x term, you got to factor in. I think we're going to have to do quite a bit of practice on some quadratic equations. So x, and I'm looking for two numbers that multiply to -6, plus 3, -2, which means that x will equal -3 or +2, and those are the vertical asymptotes. So we're going to have the same shape that we had on the previous one. It's going to look like this. So it's going to be the, well, what did I call it? Oh yeah, the erupting volcano. So we've got to do our little table of values. So we've got x and y. This vertical asymptote is -3, which means I have to try -4 and -2. This vertical asymptote is 2, which means I have to try 1 and 3. Now this is going to take us a little while because look at the thing we have to plug it into. 1 over -4 squared plus -4 minus 6. And I have to calculate that. So this is 16 minus 4, which is 12, minus 6, which is 6. Okay? So we get a sixth. So -4 is 1/6. It's down there, and I know the curve shape it takes in that section. Aren't I going to get the same thing when it's 3? Because they're mirror images of each other? So if I plug in 3, I should get this too. And we can confirm it. 1 over 3 squared plus 3 minus 6. That gives me 1 over 9 plus 3 minus 6, which is 1 over 12 minus 6, which is 1 over 6. The outside ones, the first and last ones will always be the same. And the middle two will always be the same. So whatever this y is when I plug -2 in, it'll be the same answer when I plug 1 in. So I get 1 over -2 squared plus -2 minus 6. And that, yeah, that's going to give me a negative. So 4 minus 2, -1/4, I believe. And then this one is going to be the same. It's going to work out to -1/4. So at -2, I have -1/4. At +1, I have -1/4. And it's going to, yeah, you know what? I'm going to change my mind. On the previous page, just to make things easy. Just put y not equal to 0. Just to make that easy. Okay? Let's do that. I don't want to make this complicated. So, what's our shape going to look like? Well, we're going to have a curve like this. And, oh, sorry, I forgot to plot this one. We're going to have a curve like this. And then we're going to have that upside down sort of wide parabola. Like where the middle is, just make sure you don't touch the x-axis. That's all. Keep it under the x-axis. What's that? I know we did the y-intercept, but this would be hard because you know what we'd have to plug in? We'd have to plug in -1/2 because that's the halfway point between these. So that's why I said, the reason I gave you the previous one is I just wanted to show you what the shape looks like. So just worry about drawing the shape. Because for me, I would say on this question, if I gave you a question like this, graph this, include the asymptotes, and at least 4 points. And if you put these 4 points in here, that's sufficient. Okay? So the vertical asymptotes are x equals -3 and 2. The horizontal asymptote is y equals 0. The x-intercept, because there's a horizontal asymptote at y equals 0, is none. The y-intercept, you have to plug 0 in. So you have to do 1/0² plus 0 minus 6. Right? Did I get that right? Yeah, -1/6. The domain, yeah, I know, I can't. Domain can be, can't be the vertical no, the vertical asymptotes.
That cannot be negative.
So you got to know the difference here. When you state the vertical asymptote, you got to put equals. But when you're stating the domain, you got to put not equals. And the range y cannot be 0. Yeah, just one more. And it's not going to be as complicated as this, as these ones. X² plus 2. Horizontal asymptote, y equals 0. Vertical asymptote. I need to make the denominator equal to 0. There's no x term, so I don't have to factor. I just move the 2 over and take positive and negative square root. I move the 2 over to make it -2. Take the positive and negative square root. And I get x equals, what is the square root of -2? There's no solution. Okay. Because you can't take the square root of a negative number. So what does that mean? that means there's no vertical asymptote. There's no vertical asymptote. There's only a horizontal. So how do we start with the table of values if we've got no vertical asymptote? Well, your best bet is to start around 0. So let's start 1 to the left of 0, 0 itself, and 1 to the right. What is 1 over -1 squared plus 2? Maybe you should pay attention. A third. One over 0 squared plus 2. 1/2. And this is going to be 1/3 again. And because of the horizontal asymptote, we know it's going to approach the curve or approach the asymptote, right? So it's actually going to look like this. I am serious. It looks like that, which is what I call it. I call it, no, I call it the speed bump. I call it the speed bump. Okay? So you can see what happens. When we couldn't, like when there was no vertical asymptote, the graph changed. This is the thing with rational functions, is that the graph can take so many different types of shapes. Okay? I mean, we can take a fractional or a rational function, and if you graphed it, it could actually look like a line with a hole in it. Why would you draw a dotted line down the middle? Because there's no vertical asymptote. Okay? So the vertical asymptote, none. The horizontal asymptote is still y equals 0. The x-intercept, because there's no horizontal asymptote, is none. The y-intercept, well, we found it, didn't we? In our table. It was 1/2. Now, the domain and range. We're not going to use the not equal notation. What's the furthest left to right? Remember, there's no vertical asymptote. -infinity to +infinity. It's everything. The only time it's not everything is when there's vertical asymptotes. The range goes as low as, but doesn't include.
Negative.
No, it doesn't go into the negatives.
Negative. 0, maybe? It goes as low as 1/2. 0,
It goes as low as 0, but doesn't include it. And it goes as high as 1/2. And includes it. Yep.
the domain is vertical.
When there is a vertical asymptote. Good question. No, good question.
Good.
Okay.